Good morning. In today's topic, we'll be covering modern physics. We'll be discussing how light has two natures, both wave and particle nature. Initially, it was thought that light only exists in the form of a wave by Maxwell. However, later theories proved that, according to Albert Einstein in 1905, he performed an experiment in which he had an explanation for the photoelectric effect of light, in which he theorized that light also could behave as a particle matter. Now we have to understand that in experiments such as diffraction, light it basically behaves as a wave nature. However, in other experiments, light also acts as a particle nature. Now we have these are some of the fundamental concepts of this chapter. First was the wave versus particle nature debate. Second is photons. Now, what are photons? Photons are the discrete packet of light. A photon is a mass has is massless and does not have any mass. Now, I will tell you the formula which is most important and will cover most of the important questions which you will be able to solve. E equals to hv, where h is the Planck's constant and has a value of 6.6 times 10 power minus 34. Now, as I was talking about earlier as well, that photons don't have a mass, so they aren't represented with either kilogram or grams. However, despite not having a mass, they still have a momentum. Now, if you recall in the earlier chapters that what was momentum? Momentum is basically when you multiply mass and velocity, the product of mass and velocity gives you momentum. However, although photons don't have any mass, however, they still have velocity. Therefore, they have momentum. And this is the formula P equals to E over C. And this can be easily converted into H times V over C. H is the Planck's constant. Now, how does the photon's energy depend on which factors does its energy depend on? As we can see in the formula above, that the greater the frequency of the photon, the greater will be its energy. For example, they told us that ultraviolet light has a greater energy because it has a greater frequency compared to lower frequency light such as infrared rays. Now comes the photoelectric effect, the most important concept. Whenever light strikes the surface of metal atoms, it basically emits electrons. However, it's not necessary that each time light is emitted or light strikes a certain metal, electrons will be emitted. Electrons will be only emitted when the kinetic energy of the electron which is being emitted will be greater than the photon. And here comes the concept of work function. What is the work function? Basically, work function is that when the photon strikes the surface of an electron, there is energy which is required to overcome barriers and in order to excite the electron. So this is the formula that the kinetic energy of an electron equals to hv minus the work function. And the work function is basically denoted by a phi symbol. Now we come to the quantum theory and dual nature of light, as I explained previously as well, that light exists as both a wave nature and a particle-like nature. Now, in order to basically solve some of the questions for your MCAT examination, apart from the theory, it is important that you know how to solve these questions. So here are a few of the sample questions. For they will say that calculate the energy of the photon with a frequency of 6 times 10 to the power 14 hertz. Now you know the formula E equals to hv, so you will just plug in the values. H equals is the Planck's constant. You don't have to necessarily remember or memorize this value, and v is the velocity which they have given. So the frequency is 6 times 10 power 14 hertz. So will frequency, and you plug in the values of both Planck's constant and the frequency, and you get total energy. Now we come to the next question. They asked that the photon has 3.2 times 10 power minus 19 joules energy. We have to calculate its wavelength. Now, according to the formula, we know that E equals to hv, and V is basically the speed, the frequency. We know that the formula which basically denotes the two relationships is V equals to F lambda, which means that, and we know that the speed of light is fixed. It's 3 times 10 power 8 meters per second. So we just plug in the values over here, and the answer is 4.8 times 10 to the power 14 hertz. This is the relationship between frequency and wavelength, that V equals to F lambda. And hence, because initially they had asked us about the wavelength of the light, so we will calculate it by a wavelength equals to the speed of frequency, the speed of light divided by the frequency, and it's 621 nanometers. Now, in the third question, they've asked us to calculate the total maximum kinetic energy emitted by the electrons. They've told us that the work function of the metal is 2.5 electron volt. So what should be our first thing? First thing we should know do is that we have to basically calculate the energy. And how will we calculate the energy? We will multiply 2.5 multiply with 1.6 times per times 10 raised to power minus 19 joules to get the total work function, because here they've only listed it as in electron volts. And they've also given us the frequency of the light, which is 8 times 10 to the power minus 14 to the power 14 hertz. So in order to calculate the maximum kinetic energy of the electrons, we basically plug in the values E equals to hv, where h is the Planck's constant. Over here, h is 6.6 times 10 raised to power minus 34 joules per second, and the frequency is 8 times 10 to the power 14, and we get the answer. Now, as I explained to you above as well, that the kinetic energy is when you subtract the energy of the photon from the work function, and you get the final answer is 1.3 times 10 raised to the power minus 19 joules. Now, in the last questions, they've told us to determine the momentum of a photon with the wavelength. So yeah, so you can see the pattern. They can either give us the speed or the frequency or the wavelength, and they can ask us if they've given us the wavelength, they will tell us to basically calculate the frequency, and vice versa. So the photon's momentum is P equals to h over lambda. The basic formula remains the same, E equals to hv. And over here, we've just basically gone ahead a few steps and directly written it as P equals to h over lambda. So we just plug in the values. The wavelength has been given over here, 500 times 10 raised to power minus 19, 10 raised to power minus 9, because nano means 10 raised to power minus 9. So h over lambda, and h is Planck's constant. We get the answer 1.3 times 10 raised to power minus 27 kilograms meters per second. And, now I would like that when you're watching this video, you should pause the video, and before seeing the answer to each of the question, try to solve the question on your own. So I hope these questions will help you get a better understanding of the topic, and feel free to reply in the comment section. Thank you.